Good afternoon, everybody. We will start this new session. My name is Jose Luis Sanchez. I am a local chair of this conference. And in first place, we are going to introduce Zachary Singh on behalf of Jerry Chan et al. To present the intelligent instructional design via interactive knowledge graph editing. So you can start.
Okay. So thank you, Chair, for your very kind introduction. Yes, I'm Zachary Sin, but I'm not one of the authors here for the paper. I'm only presenting on behalf of Jerry C.K. Chan et al. So we are all from the same university, the Hong Kong Polytechnic University. And today, what I bring to you is knowledge graph reciprocal instructional design, intelligent instructional design for interactive and consistent knowledge graph editing. So this paper has three key elements. It is reciprocal because what the authors have proposed is a framework that facilitate collaboration between research and education via the knowledge graph. And it is also an instructional design that is interactive and consistent when they do the knowledge graph editing. So we'll first talk about the framework. So the authors have proposed a instructional design tools that have two primary interface for instructors, so the educators, the teachers. So a course plan management interface and a knowledge graph course syllabus editor interface. I will talk more about them very soon. And the other thing is a KG technology extension API for technologists to, based on these knowledge graph, to have novel technology for them to help the educators. So you can see that the end users are our teachers and students. And we have another set of stakeholder, which is the researcher and developer. So what the interface can do is that it provides a way for the educators to feed the educational data to researcher and developer. And then the researcher and developer can, based on this educational data that is embedded into the knowledge graph, and develop advanced educational technology that can help the educators. So you can see here that we have the interface and we have a graph database which store the knowledge graph. So moving on to the ID2, which is the instructional design tools. So the design of the instructional design tools is based on trying to achieve four goals: management, visualization, collaboration, and evaluation. So these four is based on the efficacy of Andrew and Goodson and Johnson, Barlow, and Lehnen. So these are the four important factors that actually comes from management. And then so previously I said that there are two interface for the educators and teachers. So what they are is actually this. On the left side, you see a knowledge graph, and on the right side, you see a course plan. So the knowledge graph basically provide a structural representation of the syllabus. So all the educational concepts can be embedded into the knowledge graph. But at the same time, the most important thing we have in university education is the schedule, right? So week 1 study what and week 2 study what. So this is again very important. But the problem we have here is that when we change the knowledge graph, it does not match with the teaching plan. And when we change the teaching plan, it doesn't match with the knowledge graph. So what the authors have proposed is a way to somehow synchronize the left side with the right side. So you can see in the knowledge graph, for example, there is a conditional loop. It may be a little bit small for the people here on live, but there's a conditional loop which contains 4 elements: while loop, for loop, do while loop, and this can be found at the bottom left. So what we want to do is to make sure that the schedule sync with the knowledge graph. So here is a a demo. So please play the video. Thank you very much. So via the interface, the educator will be able to expand the knowledge graph. So we have a course come 1011, and then we can add the concepts that belongs to this course. So we can see that the educators are going to is adding a lot of concept into the course. So what will happen later? So please take note a bit later on the left side, you will see the teaching plan. So the teaching plan can include all of these concepts, and based on the method that is described in the paper, the teaching plan can be generated automatically based on the knowledge graph. So you can see that there's a new level of hierarchy. So we have introduction to computing, and then it has C++, process, and computer architecture as its subtopics. The same goes for pseudocode. It is subtopics to control flow. So the teaching plan should show on the left side any second now. Okay, right here. Okay. So you can see that the teaching plan, you can change the teaching plan and it will affect the knowledge graph. And it can also go vice versa. So when you change from the knowledge graph, it will also affect the teaching plan. So as you can see here. So, okay. I can go next page. Yeah, thank you very much. So with this interface, we also, sorry, the authors, not me. The authors also proposed a method of visualization for the knowledge graph. So we can use color to visualize the number of learning material that belongs to a particular concept and the student performance for a particular concept. So with that, educators will be able to know where we should add more, educational content, where maybe we should take more time in terms of scheduling to let the student have more time to learn a particular concept. So it is a very useful tool for communication among the educational colleagues. So for future work, what the authors are going to do is to predict the students' performance via machine learning methods, improve the teaching plan generation with better algorithms. So we have currently a version, but I believe so. The authors have a version in the paper, but I believe that they are going to have better algorithm in the next work, and also more methods of visualization that helps the educators on how to utilize the educational data. So these can be done by graph neural network, knowledge graph embedding, and also an improved knowledge graph construction in future work. So for the education industry, what it means is that the knowledge graph framework proposed to the authors can be used for a learning management system like Blackboard. It can also, the knowledge graph, created by the educator can also be utilized by the academic, by researchers for data mining, that sort of data analytics. So this is what I have for the paper today. Thank you very much.
Thank you very much, Zakaria.
Thank you.
I don't know if you are competent enough to answer some questions.
Maybe not, but I'll try.
Okay, I will make the question,
Okay.
and you let me know, okay?
Okay.
From a different point of view, from the pedagogical point of view, in some manner, you are doing a knowledge representation.
Yes.
Okay.
Yeah.
And in that sense, you represent a granularity of the knowledge.
Yes.
By isolated concepts.
Yes.
This is for main concepts, or you can go to deeper, to small grains. You know what I mean? One of the cells that you saw there can be expanded in more cells.
Yeah.
one of these nodes
Yes.
can be expanded to explain
Yes.
in more detail?
Yes, I think so, but it depends on how far the educators want to go. So we can see here there is a different level of, atomization, how small we want the concept to go. So how far it goes, I think, is currently one of the things we are thinking about, because I belong to the same project actually. So how far we want to go is one of the things that we are thinking about at the moment. But I think that generally, when you visit Wikipedia, right? Wikipedia, like for loop, the conditional, statement, that sort of thing. It already provides us a reference on how far current educators or current students want us to go. But it can go further, of course.
The reason of the question is that this resembles to me, the concept maps. It's a kind of concept map.
I think so, yes.
So you can improve with the significant learning for the students.
Yes.
So I mean, if they have planned, if they have the concept maps in mind, in the sense to represent the subject in a conceptual manner for the students to be able to improve their learning.
I think so, yes, I think so, yeah. I will, relay your question to the authors, and maybe you can, excite their thinking. So thank you very much.
Okay, thank you very much.
Okay.
¿Se encuentra el siguiente? Is there ¿hay alguna cuestión en la sala? Is there any question? No? Thank you very much.
Thank you very much. Thank you very much.
Está en la sala. Okay. So the next presentation will be a two-step process for analyzing teachers' behavior using a scenario-based platform from Malakanan. I don't know if I pronounce correctly. Are you online?
Yes.
Okay, can you introduce you for a little, and then
yes,
you can pass
okay.
the presentation.
Okay, thank you very much. I will share my presentation. My name is Amélie Sad. I'm the second author in the paper. So can you see my presentation?
Yes.
Okay, perfect. So thank you very much for the introduction. My name is Amélie Sad. I'm assistant professor at Sorbonne Université in France. I'm member of the Laboratory of Computer Science. And in this presentation, I'm going to talk about a work done by Malakanan in her internship last year with me. It's about a two-step process for analyzing teacher behaviors using scenario-based platform. So this research is part of the project ICA, funded by the ANR, the French National Agency of Research. The main objective of this research is to support teachers of elementary schools in teaching computational thinking concepts or skills, CTS concepts. Our hypothesis in this project is that the process of creating scenarios could engage and assist teachers to implement CT activities with their students. Often in the context of elementary school, teachers have a weak training and a weak familiarity with CT skills. So we consider that the creation of scenario can be good for them in order to improve their skills. So for this, we carried out first study in order to analyze the interactions of teachers using scenario platform. In the case of this study, we choose the platform SenoClass. You can test this platform, SENOclass, by accessing our website, senoclass.lip6.fr. So I give a fast presentation of this platform in order to you can understand the context. So SENOclass is a responsive web app developed to support elementary school teachers to create, adapt, share, and visualize pedagogical scenarios and activities. It is dedicated to the teaching of computational thinking concepts and skills. As you can see in the screenshot, the homepage of SENOclass, in the homepage of SENOclass, teacher can either create scenario from scratch or copy and adapt an existing scenario in the platform. So in the platform, there is also some well-constructed scenarios edited by authors that are available in the SENOclass, and you can also search for scenario by keywords. For each scenario implemented in the platform or available in the platform, we have several information about them. For example, the objective of the scenario, the skills that are worked on the scenario, the total time necessary to perform or to implement the scenario with the students, the organization of the activities in the scenario, the solution for the students, and more other information. Here, for example, you can see also the timeline of activity that belong to one scenario. In this timeline, we can organize the sequencing of the activities as we want. So I recall that the objective of the current study is to analyze the interactions of teachers when using scenario-based platform like SENOclass. So more precisely in this work, we try to answer the two following research questions. The first one is there different usage behaviors of teachers when using SENOclass? And the second one, if the answer to the first question is yes, what recurring patterns to characterize this teacher usage behaviors? So in order to answer these two questions, we carried out an experiment with 29 participants. 11 of them were primary school teachers, 7 were trainers of primary school teachers, and 12 were intern school teachers. Each participant has consigned to discover the platform and then to choose which functionalities of the platform to use. All the interactions of the participants with SENOclass were collected and stored in a data set. We collected in total 498 interactions. The action that are performed by the teacher using SENOclass are classified into different categories and stored in the data set. For example, we have actions about scenarios like create scenario, clone, copy scenario, delete scenario, print scenario, and so on. We have other actions about activities like create new activity, create simultaneous activity, delete activity, and so on. We have also active actions or interactions on activity fields like fill in the prerequisite skills, fill in the resources that related to the activities, and so on. And we have other type of actions that are at the platform level, like create account, and search for scenarios. So, in order to answer the two previous questions, we should to use AI algorithm to analyze data traces that are the data that are stored in the data set for detecting the usage behavior of the teachers. We used a clustering algorithm to divide data of the data set in clusters. And when the clusters are detected, we applied a pattern mining method to characterize and label each cluster. So the first step of the process is of the analysis process is the clustering. We used for the clustering the well-known Cummins algorithm. The main steps of the main task of this first step are the data pre-processing, the feature selection, and finally the Cummins clustering. For the second step of the analysis process, we have the pattern mining. For this, we used the generalized sequential patterns. It's a particular method of patterns mining on the data, but only on each cluster separately. So the more in the step of the clustering, the more complicated task was the selection of the features as input of the clustering algorithm in order to obtain a good clustering. For this, for the selection of the features, we conducted an iterative process. And finally, for the data we have, we obtained 3 features that have a good clustering. The 3 features are the number of the viewing activities. The second feature is the number of copying scenarios, and the third feature is the number of consulting solutions in the classroom, in the Senoclass. These features allow us to maximize the average centroid distance and thus obtain enough 4 different clusters. The 4 clusters that we detected, we can interpret them because we have a low number of traces. If we were in massive data, the interpretation will be impossible. But here we can interpret the clusters because we have low number of data. For example, for the cluster 0, the participants, it represents the participants that were mainly interested in copying scenarios and less in consulting existing scenarios. For the cluster 1, the participants explored the platform, the global platform, and tested different functionalities. For the cluster 2, the participants were interested in the activities, specifically their description and sometimes their solutions. And finally, for the cluster 3, the participants were mainly interested in the solutions of the activities and less in their description in terms of competences. So after the clustering and after having these 4 clusters, we applied the pattern mining algorithm. We choose to use the FP-GROW algorithm. It's a particular, it's an example of pattern mining algorithms. However, because we apply the pattern mining, even we haven't massive data. But in general case, when we have massive data, this step is necessary to interpret the clusters. because the interpretation of the cluster become very hard and even impossible. So when we apply the FP-GROW algorithms, we obtain, we can interpret the four previous clusters, for example, and the results point in the same direction that the first interpretation after the clustering. It allows us to interpret each cluster as the following. The participants of the cluster 0 are adapters because they create scenarios and are less likely to visualize existing activities or existing scenarios in the platform. For the cluster 1, the participants are explorers because they explore the platform and test different functionalities. For the cluster 2, these participants are mainly the viewers because they visualize different activities and scenarios and didn't create any scenarios. For the last cluster 3, this cluster is typically participants that are beginners because they want to be reassured about their ability to solve activity, and they are mainly interested in consulting solution about the activities. So the two-step process allow us to divide data in different clusters, and after that, in the second step, we can interpret the meaning of each cluster. So I can summarize the contribution of this research like this. We defined it with Malak a two-step process for analyzing the teacher interaction when using scenario platforms like SenoClass. The first results, it's an ongoing research. The first results are promising, but the process has to be more evaluated with more interaction data. And concerning the future agenda of this research, we have to improve the SenoClass human-machine interface to improve the usability of the platform. And we have to design feedbacks to help teachers using SenoClass and in order to prepare their classroom session on teaching SETE skills to their students. Thank you very much for your attention.
I would like to ask you a question. You mean that one of the objectives for the future is to help teachers on how to use SenoClass, but have you considered to study the students when they receive those classes?
I don't listen the first part of your question. Sorry, can you repeat, please?
Yes. I mean, the study is focused on analyzing the teacher interaction.
Yes.
What I like to know if you have considered to study student interaction when they receive those classes.
The platform is dedicated to the teachers. The students don't use the classroom. Okay. The teacher use the SenoClass in order to prepare their classroom session. Okay. Because we observe that in the context of the project that in France, particularly, the teacher of elementary schools have a weak training on the SETE skills, and they are very beginner in using implementing this type of activities about SETE skills. So the platform is dedicated to teacher to help them to gap to compensate and to help them to prepare their classroom session.
Okay, thank you very much. Is there any other question in the room? Yes.
Hello, yeah, thanks for your presentation. I was wondering, you said you had different types of teachers that were using or participating in your study. Did you cross-reference that with the results as well? Like where the beginner cluster, were those also more beginner teachers, or were these clusters not related to kind of the types of teachers like primary, secondary, I'm not sure you said supplement teachers or
Yeah, I don't know if we cannot relate the data or the traces to the persons. So we can't because in France we have a strong rules in order to store data of persons. So in this first study, we haven't any relation between, we can't relate the identity of the person, so the background and the experience of the person with the data in the platform.
Okay, so not even
Lately,
anonymized, like this was a type of that teacher.
Yeah. Unfortunately,
Okay, yeah,
we can
okay,
see, but in the yes, but in the future we prepare other studies, and we have resolved this problem. And in the future we can relate the data to the persons, and so it's interesting to consider to see if the beginners in the cluster beginners correspond really to the beginners persons or teachers. Yes.
Okay.
Of course.
Great. Yeah. Thank you very much for the clarification. There's
Thank
a
you.
question next to me. I'll just hand the microphone over.
Hello. So I understand that the 4 different types of educators that you've identified relates to scenario-based platform.
Yeah. Yes.
Can you also, in your opinion, or maybe there's an existing study, can it also be generalized to other different platforms, for example, serious games, authoring tools?
Yeah, I don't know if we can generalize else, but the ambition of this research is to generalize the process. So the process of 2 steps. The first step, the clustering, and after that, once we have the clusters, come to label each cluster, but pattern mining. This process, we would like to generalize it. I think that we can generalize this process, but the results that we have after analyzing the data of single class, I don't know if we can generalize it to other platforms like service games, like as you say. But the process, the idea is to generalize the process, but not the results of the process.
Right, understood. Thank you.
Any other question in the room? No? Any question for the people who is online? No, so we finish here. Thank you very much, Amel.
Thank you very much.
So now we pass to the next presentation. New digital trends to teach soft skills and sustainability for the labor market gamification as a tool for competency acquisition in realistic context. Nadia McCowan is here.
Here I am. I'm just about to share my screen.
Okay.
Is everything working correctly?
Yes, we can see.
Fantastic. So, thank you for the chance to be here today and present this small study with a very long name. As you have just introduced it, it is the joint result of the work performed by Aida López Serrano, the first author. I am the second author. Daniel Burgos and Pablo Moreno-Ger. We belong to Universidad Internacional de La Rioja here in Spain. So as a starting question, have you ever had to select a candidate for a job position and wondered who to pick among two similar CVs. Who did you go with? Probably with whoever seemed to communicate better, solve problems in a more effective way, or seem a better teammate. All these valuable traits are soft skills. When we talk about soft skills, we're talking about personal attributes that can be useful in any situation. And the odds are that if you are deciding who to give a job to and two applicants have equivalent technical knowledge, the one with the better soft skills will get the job. We're talking about skills such as teamwork, being able to communicate effectively, how to handle stress, or simply having problem-solving abilities. The modern workplace demands well-prepared people, but being well-prepared nowadays also includes these abilities other than academic and technical knowledge. Soft skills are a need. Higher education students are preparing themselves for their entry into the labor market. So the university is an ideal point to help them improve these skills if they haven't acquired them by that time. But they're hard to teach and they're hard to learn. And that is why gamification can be a good choice to help interiorize them, to help acquire them. You can read a lot about effective teamwork, but studying it alone won't make a difference. That is why we proposed a game. It's a serious game, single player, can be played online. You have the address right underneath the logo. It's called Compete. It's a serious game aimed at making higher education students aware of the importance of these soft skill competencies. We focus on the impact they can have in a professional and personal setting. This serious game was developed within the Erasmus Plus framework. It's a tool to help students critically apply and identify these skills and discuss their impact within a classroom setting. We also put a strong focus on the feedback we give the students on the decisions they have taken. We try to integrate assessment into the game design. This helps them better understand the impact of their choices and how these reflect skill acquisition. The goal, of course, is to help them improve. That's what we always try to do with students, don't we? Educational games must strike a balance between education and entertainment. Edutainment generally holds negative connotations, but games must provide a certain sense of fun to the player. So how did we go around the game design? First of all, we identified which soft skills we wanted to include. Having selected these, a storyline was designed to maximize their impact. This can more or less be the fun part. And finally, assessment methods were developed for the game based on soft skill competency acquisition measurement. The soft skills selected were creative problem solving, effective communication, stress management, and teamwork. The storyline uses sustainability as its focus. The player takes the role of a new project manager on an island based on Ecuadorian territories. You have to advise the local government and help them develop the local economy in a sustainable manner while keeping the local residents happy. Here we have two axes, economy and sustainability. The players will have both social and economic impact depending on their decisions. The narrative is divided into 2 introductory tasks and 10 challenges, which are the ones you can see here. Each challenge is a unique scenario where social or environmental problems are presented. So the structure of each scene, each challenge, each chapter, as you wish to divide it, is we introduce the storyline. The player is given a first task. He must pick between 2 possible choices to complete this task. Each choice will help measure specific soft skill competencies. Once he has made this choice, he has access to his counselors who give him their opinion on different courses of action. The player decides which counselor gives him the best possible option, and this choice will be assessed based on its sustainability and social impact. We repeat this challenge after challenge after challenge until we get to the end of the game where the player gets a final report or debrief. So for example, in the first scenario, the CEO of a big company wants to build an exclusive resort in our island. The design will be eco-friendly, but will only host a very limited number of very exclusive tourists. They will require 100 linear meters of coast and permits to build on our beautiful, natural, untouched beaches. So What do? We have to decide before lunchtime, or they will go to the country next door. So here the player is given two different choices. Depending on what they pick, the counselors will give them different options. Here we have the 5 different counselors they have, which repeat challenge after challenge, each one of them with their own personality. In this case, for example, Martin suggests we reject the offer because it will negatively affect the ecosystem. Another one suggests we build our own hotel, and so on. Depending on what we pick, we will get results based on how sustainable our choices were and how they will positively affect the local community. This is measured in the following way. Soft skill competencies are measured independently from social and economic impact. Each soft skill is measured in 3 dimensions, and each dimension is measured using a right or wrong A or B decision. Social and economic impact are measured through sustainability and island happiness, and both are linked by the answers given to the competency measurement task. If we get the competency right, we can have access to the best possible option within island happiness and social and economic impact. If not, that counselor will tell us that he cannot help us and explain why he cannot. This shows the impact of not having a good application of soft skills directly into the storyline. The impact of the social and economic impact is measured from 0 to 15 points, depending on the choice we make. At the end of each challenge, each scene provides feedback to the players regarding their choices. They are divided into 2 sections. The first one shares the results related to the socioeconomic impact. And in the lower half, we have the soft skill competency associated with the challenge. In this case, other courses of action are suggested. In the final report, we go through all the comments given for each challenge. We add up the points acquired, and that gives us different score categories where 4 stars would be an expert, no stars would be a newbie. And this can help students or players more or less gain an insight of how they fared. Compete can be used in classroom settings as part of active teaching learning in a cross-curricular environment. The game is aimed at fostering active dialogue, which can be used to increase student engagement. It aims to increase higher education student employability by improving their soft skill competencies while also raising awareness regarding sustainability issues embedded in the storyline. Given that the choices made by players have an economic and social impact, higher awareness of these issues is also expected as a result. And well, we hope you liked our proposal. Thank you for your time.
Thank you very much.
And I would like to say that after Yesat's presentation, once we actually tested in a classroom environment, I would very much like to apply her clustering and pattern mining proposal to the results we get. I think that could be a future interesting line. See?
Sorry, can you repeat that the last?
Yes, in the previous presentation, Ahmed Yesat proposed a method of clustering and pattern mining, which she applied to her study. And I think that's something that we could apply here once we have results, measurements in a classroom setting.
Okay, thank you very much. So have you made any evaluation? Yes. How good is those tools for improving the learning of those soft skills?
For the time being, we've gone as far as designing the game. Now we need to do the implementation in classroom settings. We're hoping to do this in the following months.
Okay, thank you very much.
Very welcome.
Is there any question in the room?
Yeah, thanks for the presentation. I've got a question about your measurement of creative problem-solving skills, because as I understood it, all the problem-solving was basically done by the different helpers. I don't know what exactly you called them, supervisors that you could call. So how can you, so the problem solving, the creative problem solving didn't come from the student, it was presented to them as one of the options. So it was picking of a creative problem solution, but not actually coming up with one themselves. Did you look into, is there a difference between those, or can you make that connection and say, if they pick a creative problem solution, then they would also have come up with a creative problem solving themselves?
Yes, that's something. That's a problem that shows up with most of the different skills. It's not the same thing to pick between two options than to actually work as a team, for example, or to actually come up with a creative idea.
Yeah.
That's obviously a limitation. What we do here is we present the scenarios, we give them options where they can, where one of the options applies this skill and one doesn't, and hope to also increase the awareness to the dialogue within a classroom setting. Normally, most of the answers can have a way of being defended. Actually, that caused some controversies between the people working on it. Which one is correct? Which one is better? That dialogue within a classroom setting with your classmates can also help increase this awareness and improve these skills.
Okay, thank you very much.
Very welcome.
Any other question? No? Some question from the people online? No? Thank you very much, Nadia.
Thank you.
Now we pass to the next presentation, Pocket English Master, Language Learning with Reinforcement Learning, Augmented Reality and Artificial Intelligence. Dilaine Gunasekara is here? Or some of the team, or some people of the team?
I'm from Pocket English Master Research Component. I'm Ashini. I'm the first author of the research. So let me share my screen.
So can you make the presentation?
Yeah, hope you can see my screen. So our research component is Pocket English Master. So it is a mobile application which is built for English language learning with reinforcement learning, augmented reality, and machine learning. So our authors are myself and so our authors are myself, Dilaine Gunasekara, Kamdu Vimalavira, Dr. Kalpani Manatunga, Manohari Madhumage, and Ms. Devanshi Ganigoda. So the English is one of the most widely used language in the world. According to the marketing and research website, there is more than 1.35 billion users are using English as their main language as well as the second language. So most of the English learners are depending on English learning platforms. So with the pandemic and all the situations, or all these e-learning platforms has become more popular, and even the more educational institutions also move to the e-learning platforms. So when with the advances in new technologies such as reinforcement learning, machine learning, artificial intelligence, and augmented reality, it is allow the static learning to the more dynamic and interactive media content to give to the students. So our research problem is most of the I'm from Sri Lanka. So in Sri Lanka, we are studying 13 years in school. So 90% of our education is based on Sinhala. So Sinhala is our mother tongue. But the thing is, when we go to the higher education universities, all the programs are in English. But even though students understand English, they don't know how to properly speak. They don't have confidence to go on a stage and perform. The thing is, if the student is from a where in a good city, they can speak English, but students are from rural areas, they cannot find someone to speak, and they don't have anyone to practice. So we have found four main problems. The first one is lack of opportunities for individuals to develop English speaking skills independently. The second problem is lack of opportunities for individuals to practice picture description independently. The third one is inability to detect grammatical errors in handwritten text. And the fourth one is lack of adaptive e-learning systems with according to the specific need of the individual learner. So this is our solution. In our solution, we have four main sub-components. The first one is reinforcement learning based component, and the second one is augmented reality based grammar and spelling checker. The third one is picture description generator, and the last one is conversational speaking bot component. So let's go by one component. So the main objective of this component, the conversational speaking bot component, is to improve the learner's English speaking and listening skills. So by identify grammar and mispronunciation issues in speech. And also we provide conversational simulators to practice speaking to the learner. So this is the methodology. So in here we are taking user's voice as the input. As the output, we detect mispronunciation, and also we are converting audio into text, and also we are detecting the grammar errors, and also we are auto-generating a reply. And also if the student wants to listen to the conversation again, we are converting text into audio also. So as the result, for the speech to text component, we are using wave-to-wake model with the Libri speech dataset. And also to text-to-speech component, we are using fast speech 2 model with FairSec toolkit with the LJ speech dataset. For the chatbot component, we are using Facebook BlenderBot 400 and Distill model. And also to detect mispronunciation, we are using T5 model, which is also known as text-to-text transformer. And also to detect grammar errors, we are using Python wrapper for language tool. So this is the output. So this is the UI we implemented for our mobile application. As you can see, when the user send a response with the grammar error, it will automatically generate in the correct form. And also according to the user's response, the bot generating a response too. So if the user want to hear, then they can hear it from here. Listen to the text from here. So our next component is picture description generator component. In here, our main objective is to utilize the machine learning and deep learning to enhance the learner's ability to describe pictures by creating a platform where learners can get generated picture descriptions. So in here, we are providing real-time picture descriptions so in here is the methodology. In here, when the user can upload the image by using the mobile application. So using the conversational neural network, it will generate the picture description in the real time. So in here, we are using the Flickr 8K dataset, and also this Flickr 8K dataset is for generating single sentences. So we implemented this component to generate multi sentences. So we have to create a custom data set for multi sentences. So this component achieve an average of 0.4 blue score out of 10 tests. So this is the UIs we implemented. As you can see, when the user uploaded an image, the picture description have been generated. So our next component is grammar checker with augmented reality. So in here, what we wanted to do, what we wanted to address is when the learners, we want to encourage learners to do handwriting. So when we do handwriting in self-learning environment, it is very difficult to find grammatical and spelling errors. So what user have to do is user can scan their text, then it will converted into the uh, uh, scan their document, it will convert it into the text and display in the screen. So in here there are some mistakes, so it will detect in the spellings and grammar mistakes, and they can identify what they did, the mistakes they have done. So in here we as a data set we used IAMI data set. For the test recognition accuracy is character rate of 3.42, and the text detection accuracy is F1 score of 96.34. So this is the augmented reality part. So in here, as you can see, it is displaying in the here. So the other next component is adaptive learning component. The problem we are addressing here is the lack of adaptive e-learning systems. So in here, so our main objective is to provide more adaptive and efficient English learning mobile application, which has more accuracy according to the user characteristics. So the flow of the control, we have an initial exam to identify the prior knowledge of the learner. So it is a rule-based approach for score calculation. So after that, by using the score, we are categorizing the user. Then course display according to the user level. So and there are some topic tests. Then we analyze the student via Q learning algorithm. Then we will provide the next best lesson according to the user's progress. So this is the methodology. So this is the results we got. So initial graph and the initial metric. So these are the UIs we implemented. This is the initial examination we are providing for student to get to know their prior knowledge. So these are the admin dashboard we implemented to insert the questions to initial examination. So as conclusion, our main objective of this component is to enhance the user's English learning in modern way and using the new technologies. So so we proposed 4 subcomponents. The first one is conversational speaking, to give them opportunity to practice speaking, and the pitch description generator to practice picture description independently. The third one is grammar checker with augmented reality to encourage them for writing. And the last one is adaptive learning system, which is an adaptive e-learning system where user can customize their learning materials, and it is categorizing the user. So as the future work, we are planning to do a certificate at the completion. So, and also we need to fine tune some machine learning algorithms to provide a better and accurate experience. And also we are planning to add new unique features such as game for English practicing. So the learner is more interact with the mobile application. Thank you.
Thank you very much, Asini. I think that you have developed a very, very interesting and very complicated tool. Have you evaluated in some manner with some students, at least a minor number, to check if their user experience with the tool?
We actually we selected some group of students, around 20 students in our university, and we gave we implemented these 4 components separately. So we did unit testing for each component, and actually there are so many things to enhance in this mobile application. So yeah.
Thank you very much. Is there any other question in the room?
Yes, thanks for your presentation. I have a question about the first part, the chatbot. So we yesterday in the session, we had the automatic subtitles on, and they were quite impressive, but also quite often quite wrong. So what's your experience with this chatbot? How accurate is it, and how good can you have a conversation with that chatbot?
So previously I wanted to implement this conversation. So when the learner I wanted to implement this based on scenarios. But in here, what we do is general conversation. So the bot is generating the bot's answers by considering the user's previous answer. So it doesn't consider the previous the history of the chat. So there is a point where I need to enhance, because this reply is based on this reply, the user's the previous reply.
Okay, so it's just the one reply above and not any other replies.
Yeah, because yeah.
Okay, yeah, thank you very much.
Thank you. Is there any other question? From some person who is online? Any question? No, thank you very much.
Thank you so much for giving me this opportunity.
Now the next presentation will be automated assessment in computer science, a bibliometric analysis of the literature. From Jose Carlos Paiva is here.
Yes.
Okay, so you can start when you like.
Okay, thank you. I'm sharing the screen. Are you seeing? Okay.
Yes, we see your presentation.
So I'm Jose Carlos Paiva, and I'll present the paper Automated Assessment in Computer Science, a bibliometric analysis of the literature. Authors with my 2 PhD advisors, Albert Figueira and José Paulo Leal. First, I'll introduce the paper and the research questions. Then I'll summarize how we collected publications. After, I will provide the answer to each research question. And finally, a little discussion of the results. So it is clear that practice is the key to learning how to program. The learners need to solve a broad range of programming challenges, always accompanied with timely and accurate feedback. As instructors are not able to deliver such feedback, automated assessment tools are the common solution to this problem. These tools have been part of computer science education for many years, and research efforts to improve them are reported in several systematic literature reviews done during the years. However, there is no bibliometric study to measure interrelationships and impacts of publications, or the most productive researchers are trends in this research area, at least of our knowledge. So we prepared some research questions. The first for summarizing the collected data, what has been the annual scientific production, the average time interval for a new publication to get first citation, and which are the main journals and conferences. About the authors, who are the most productive, more active lately, and who has more impact. Do the most productive authors publish alone or in groups? what are the corresponding main affiliation of these authors? Regarding citations, the most influential, the most relevant co-citations, and about the topics, the basic, niche, modern, and emerging topics in this research area. How did they evolve during the past decade? What is mostly discussed in this area? And if there are significant differences in topics if we see their early frequency. So we have used the Web of Science core collection, used that query over there, limited the publication date from 2010 to 2020, so the decade, and selected some Web of Science categories to limit the research results. We have obtained a large set with several unrelated publications. So we have presented the titles and abstracts one by one and applied an inclusion exclusion criteria that was applied also in the 2022 systematic literature review. So we have obtained 592 publications for our analysis. So the figure on the left shows a visualization on the number of publications per year with a linear trend and associated confidence interval, which responds to question 1.1. It is noticeable the increasing research interest in the area. The slight decrease in the number of publications in 2019 and 2020 is related to the COVID pandemic crisis. The figure on the right shows the average and median citations of a document per year of publication. So question 1.2 takes an average of 8.82 months to receive the first citation in a new publication. Publications are distributed among 361 different sources, and the top 25 are present in this figure. So response to question 1.3. In the question 2.1, we want the most productive authors. So the authors who have made more publications. We show the top 10 sorted in descending order from top to bottom who have made more contributions to the field. And for each of them, the number of citations per year and publications. The authors who are more active recently are Fraser and Edwards, clearly. And those who were more active at the beginning of the decade were Chi, Queiroz, and Liao. The most impactful works are that of Fraser. We can see the blue, the dark blue there, and Kim also. So if the authors publish alone or in groups, they always publish in at least two authors. Only Queiroz publishes alone. Regarding the authors' affiliations, there are 636 different affiliations identifiers. Carnegie Mellon is the institution with most publications, 21, and we show the other 20 in this image. So to answer the question 3.1, we can consider publication citations only in our set of collected publications or globally. If we consider only citations in our set, these 5 are the publications with most citations within our set. And if we consider globally, we have mostly citations to publications with for producing feedback. So this slide. So in order to identify the most relevant co-citations from our collection, we have made a chronological network map, and we have identified 6 separate groups. The light blue with works on automated feedback for computer science projects. The purple captures works exploring the automated assessment of computational thinking skills of novice programmers. The green includes publication on automated program repair techniques and tools. The yellow automated assessment tools for assessing code and test quality. The red includes works integrating automated assessment tools with other e-learning tools. And the blue captures a group of works aiming to improve feedback in automated assessment. So regarding the topics, for the first question, the answer is provided in this thematic map based on the analysis of covered networks and clustering using the author's keywords, the keywords that the authors associated with their own paper. It identifies 4 types of topics based on density and centrality. The emerging or declining, we can see a cluster involving feedback and another involving machine learning techniques and automated program repair. In the niche topics, we can see program synthesis and program refactoring. Regarding motor topics, static analysis is what is clearly noticeable. And the basic topic, we have symbolic execution. So if we divide the details in 3 sections to analyze what has been explored during the decades, we can notice the evolution of static analysis and ramifications to testing tools and machine learning. And the disclosure of techniques important for feedback purposes, such as the fault localization, automated test generation for counterexamples, and automated program repair. For question 3 of the group regarding topics, we have used the 2 grams extracted from the abstract, not the outer keywords. So this image presents a conceptual structure map using multiple correspondence analysis and clustering of a bipartite network. We have separated in 4 clusters. So blue captures terms related to program repair. The green includes terms related to testing techniques and evaluated facets of a program. The red one contains static analysis techniques, and the purple terms related to tools and systems in automated assessment. Finally, we have made a neat map to answer the last question, also using the 2 grams of the abstract. We have separated by year, and we have selected the 10 most frequent 2 grams. So it is clear the increasing interest over the years in static analysis, automated program repair, and automated test generation. Less visible but also noticeable is the increasing interest in machine learning and learning analytics for these tools. So we have compared to the results of the latest systematic literature review. We collaborate the recent focus on static analysis approaches, the introduction of techniques from other research areas. We have also seen that running the program against a set of test cases is still the dominating strategy for automated assessment of programming assignments. And we have noticed also the growing interest in integrating learning analytics into automated assessment tools. Unfortunately, the last systematic literature review identifies a new era of containerization of these tools, but with our study, we could not corroborate this trend. So that's it.
Thank you. Have you finished?
Yes, yes.
Thank you very much. I think it's a very interesting paper about how it has evolved all those problems on learning computer science. Has anybody a question in the room about that? No? Is there any person online who likes to ask some question? No? So we pass then to the next presentation. Thank you very much.
Thank you.
An intelligent chatbot supporting students in massive open online courses. Is Alessio Calabrese by here or Marco Temperini? Okay.
Yes, I'm presenting.
You can start when you like.
Okay, thank you. Thank you. I am Marco, and I'm presenting this this work we have done together, the authors you see. And the work is about the chatbot system that is supposed to help the students, the learners, in a special moment of their life, which happens frequently when the teacher is not available to answer their question. So, but what are the problems? I mean, this is the problem that happens, of course, quite hugely in the case of massive open online courses. This is the reason for the stress we put about MOOCs in the title. However, this happens everywhere, in any class environment, in any educational environment. What are the problems of that? I mean, you can imagine that the learner is not always ripe in order to give questions. So when is the moment that the student, the learner is having a question that would like to be answered? Probably that's the moment when the answer should come as soon as possible. And if the teacher is not there, of course, to answer, we should develop some other means to do that. Otherwise, we can risk that these problems that are listed here, I'm not describing all of them, but you can imagine, could hinder in some way the motivation and the engagement of the learner. So that's the idea, providing the learner with some answer, in any case, also an automated answer, of course, but with some alternatives that help to keep the learner into the learning process. So there are several methods to do that, of course. You see several methods and techniques listed here. I'm not discussing about them, of course. Some of them is specific for, is more often used in MOOCs rather than elsewhere, but all of them actually can be used in any kind of environment. And the main idea in our work is that maybe with the chatbot we can help this situation in order to produce an answer that is given as soon as possible, and possibly also building fresh automated answers to a fresh question, and anyway involve the learner in a process in which there are alternatives to the official best answer that could be given. So what is a chatbot? You know, it's an agent, it's a software agent basically, and the idea is that the software agent is able to have a conversation, maintain a conversation with a human in some natural way, of course, processing natural language, in our case, is textual. Natural language is not, there is no voice recognition involved. And also, to some extent, modeling the user. Actually, the chatbot technology is an application of research in the fields of artificial intelligence and human-computer interaction. The idea is that the chatbot is able, during this conversation, to react in a suitable way. And the reactions here, if you see the various areas in which chatbot are applied nowadays, the reactions could be answer to a question, could be recommendation about something to do, could be, in the case of healthcare, diagnosis, or suggestion about medical treatment, and so on. The study about chatbot actually, or chatterbot, like they were called, dates back till the 60s of the previous millennium, so to say. And there were applications that were able to mimic the behavior of a human in discussing with another human. And they were, I cannot go into details, just I will remind that Eliza was a parody of a psychologist, just because it was able to revert a question every sentences that were given by the patient. So actually it was, by definition, a parody of the psychologist. But then there were other applications, and they were based on the techniques that were given by computer science studies in all these years. So pattern matching, related semantic analysis and things. And they have been developing into virtual personal assistants that we know nowadays, that we have in our telephone nowadays. So Siri, there is Alexa, it's not on the telephone. There is Google Assistant and these things. Now, actually, in the not very many last years, the research in this subject has been really increasing very much. With production of hundreds and thousands of works about that, only in the last 7 or 8 years, maybe. And this is due to the fact that new techniques have been developed, algorithms for machine learning, and neural network developments into deep learning. So a chatbot, of course, can be used in educational context, and the idea is that it is used to help possibly the learner to keep their pace. Oh, sorry. You see the presentation now?
Yes.
Yeah.
Yes.
Yeah, there was some glitch here. So keep their pace in what sense? In the sense that was mentioned in the beginning, when the student maybe should be pushed to work a little bit on their own on some problem, and then be able to develop a question that could be a solving question, can be an important question, and also develop an attitude such that the question can be given to the teacher when the teacher is available for an exchange. But in the meanwhile, the teacher is not available. So our proposal is to actually, in this big sea of research, our small proposal is to make a system in which the question is given by the learner under the form of text in natural language. And then we try to give answer in different ways, in 4 progressive levels of service, as we say in the paper. I mean, the first one was what probably is the best way to answer the question. I mean, there is an item in a list of frequently asked questions, and they have been developed by the teacher thinking about the question. And if and this answer probably is well developed and can be very useful for the learner. So if the question of the learner is in some way associated with the question that this FAQ was answering, we can propose this as an answer to the question. And this is the first level, and probably the most fortunate, but not always it is possible. So we think there could be other levels of answer. And of course, the second level is to build up a new answer out of the context of the subject matter of the course in which the question is arising. By context, we mean basically the collection of the learning materials of the course that have been fed into the system and can be used in a certain way in order to extract an answer, a new answer to this unprecedented, not precedently answered question. If the learner is not satisfied, or if the answer is considered insufficient by the learner, then we can have a last level of reaction, which is the suggestion of links taken from Wikipedia. And of course, the very last one is when we have to admit that we have the answer, and also the readings that you were suggesting are not enough. So we will, of course, need to summon the teacher in some way and ask the teacher to make this new answer. And maybe this new answer will be part of the list of frequently asked questions next time. Possible, not necessarily. So about the technology that we used, I cannot go very much in detail, of course. Basically, the core of the system is this BERT system, which is a deep learning system, which is an implementation of a model of deep learning, which is called transformation. Basically, the idea is that, okay, sentences are manipulated, are processed, words in the sentence are given a weight depending on their position in the sentence, and the system try to understand the meaning of a sentence in this way, managing these weights by means of a so-called attention mechanism. And another characteristic of this model of transformation is the fact that they can be pre-trained and fine-tuned. Pre-training means to feed into the system large amount of text in order to train their comprehension of the text. And this large amount of text are data sets such as Wikipedia, or parts of Wikipedia, an initiative called Common Crawl, for instance, which is collecting text and textual resources in natural languages since a decade now. And in our case, we use a Squad, which is a collection, very probably in our case, because it is a huge collection of questions and answers used into the system in order to train the system to be able to recognize the similarity of questions and the possibility, and also be able to extract from text a possible answer. Actually, we didn't fine-tune our system yet. However, this possibility is important because basically with the same means using during the pre-trained, specific contents coming from the subject matter in which we are working can be fed into the system in order to make it more acquainted with the subject matter, more able to give answers to the point. This is basically the architecture of the system. You see there are several modules. Maybe we will mention this module while I do some examples. However, you see there is an interface where the learner and also the instructor can interact with the system, and there is a big module which is the one trying to build the answers or the various levels of answers. So here, when you see question, this is what I called the first level of answer earlier, when the question was extracted by the FAQ list. When this is not okay, there are the other levels, 2, 3, and 4, where the level 4 of answer is when we ask to the teacher. So actually, one of the weakness of this work, of course, is the fact that we haven't yet experimented the system on the field. So what I can present you is a set of examples of use, case studies, say, in order just to see how the system works. This is the first level. In the first level, you remember the FAQ model in this system is used by the request and data manager in order to prepare an answer. And in this case, the preparation consists in the selection from the FAQ list of a suitable frequently asked question with the related answer. And to recognize how this particular item in the FAQ list is suitable, we encode the question using BERT encode the content of the FAQ list and make this selection. And then after the question that is given by the learner, an FAQ is selected and given for presentation to the learner. This is an example of what happens when we give this kind of question. We have an answer that is argumenting about recursion and a particular programming technique. And this is being prepared, we can imagine, by the teacher with care and so on. So it's a good answer. Of course, it could be possible that the question cannot be answered in this way. And so we have the second level of answer is exemplified here. In this case, the answer is not taken from here, from the FAQ repository, but is taken from the context of the course in which we are. I mean, the learning material in textual, so far, purely textual format. And again, the question is encoded using BERT, and the content of the learning material also is as well encoded. And from the content of the learning material, an answer, possibly suitable, is extracted to be given, to be presented to the learner. And here we have an example, actually a couple of examples I prepared for you. This is the first example. And what you can see here is that, well, this is less effusive than the teacher probably, so it's much more synthetic. And the answer, the question is the same of the previous slide, and here we have a very synthetic answer, probably not completely satisfactory. In this second example, so everything is the same with regard to the modules that are activated. Here we have a different question, which could ask for a deeper analysis of the learning content. And this is the result. And again, like earlier, the answer is correct, but it's quite synthetic, quite curt. And this is probably because, as I said earlier, we haven't fine-tuned this system yet in this case, on computer science. I mean, our interpretation is this. We hope to get better results when we will have fine-tuned the system. The next example is quite simple. We have a module that is able to, so here BERT is not involved. We have a module that is able to converse with Wikipedia and to get, according to methods used by Wikipedia in certain libraries, APIs available from Wikipedia, according to associating a link or more links to the question, and this link is what is served to the learner as an answer. So, what is Python recursion in particular? Well, the very general answer is this with this page that we can consider as a suggestion for further reading, while we try to get a better answer. And the better answer, of course, is obtained when the teacher does it, makes it up. And this is there is no particular module employed here. The question data manager is going to ask the teacher presenting the question and asking for an answer that should be added into the frequently asked question. And this is the last of this case study. So basically, this is the system. I mean, we have a question and we try to build progressively an evolving answer, trying to give alternatives as far as we can, of course. And when all fails, of course, we have to ask the teacher for a more precise answer. And in this way, we hope that we can diminish this bad effect that the lateness or lack of an answer, or maybe the presence of an answer which is not completely to the point, as it has been built by this system that you have seen, is the only alternative that we give to the learner, and so hurting probably the motivation. In terms of future work, I think that I'm not going to discuss everything, the first item here is experimentation, because we have to experiment. Probably we'll experiment, we will make a limited experimentation only with teachers, and then we will make a field experiment on a larger set of users and also of learning material. And then, of course, we have to fine-tune the system. And the last things in the future work are about the FAQ list that can be enhanced in several ways. We are thinking of a social system able to enrich the FAQ list with the newly baked answers given by the system. That cannot be added automatically, of course, but should be analyzed. Maybe by the students, by the learners, and of course by the teacher. Oh, that's basically it. And thank you for listening so far. And I'm done. So
thank you very much. Is there any question in the room? Yes.
Hello, thank you very much for the presentation.
Hello.
An issue that I hear a lot is that students say, I'm so lost, I don't even know what to ask for. Does your chatbot maybe provide an opportunity there, like questioning back, okay, what do you already know, to figure out where the problem lies?
Well, in the medium or long run, the idea would be that, I mean, to allow the learner to mature a little bit, working on their own, with some help, of course. But we know that the help could be not sufficient. We also know that baking up a new answer to a question that has never been asked and never been answered could have insufficiency in the content, because well, BERT is not magic. Any other method that we can use is not magic, and so but this could be an initial help. And the idea that the student develops something in his mind or her mind before of just trying to discuss this with the teacher. Sooner or later, the teacher will be available. Okay. But in the meanwhile, the learner has had the opportunity to mature, to become ripen, let's say, in order to be probably with a better attitude and with more comprehension when the final answer, final question is given a final answer.
Okay, yeah, thank you very much.
Thank you, Theo, for the question.
Thank you. Is any other question in the room? Somebody online likes to make a question? No? Thank you very much then, and we proceed to close this session. Thank you to all of you.
Thank you. Bye-bye.
Okay. Okay, we are going to start with the last session of today. So my name is Cándido Caballero Gil, and the first presentation, the first talk today is constructing low, redundant, and high accuracy knowledge graph for education that will be presented for Mr. Zachary.
Yes. Thank you, Chair, for your very kind introduction. So again, I am not the authors of this paper. Okay. So yeah. So hi, I'm Zachary. I'm Zachary Sin. I'm going to present constructing low redundant and high accuracy knowledge graphs for education. But I'm not the authors for this paper. I'm only presenting on behalf of Wen Tao Li et al. So before I talk into the meat of the paper today, I'm going to give a background to knowledge graph. So a knowledge graph is basically formed by triples. So a triples is basically a description of a relationship. For example, Geoffrey Hilton is a researcher. Oh, so yeah. So a knowledge graph consists of relationships, and a relationship, for example, for this one, Geoffrey Hilton is a researcher, is formed by the subject, Geoffrey Hilton, the object, researcher, and the predicate is a. So by using this kind of triples, we have various of applications such as search, recommendations, and question answering. But our main concern here is what knowledge graph can do for education. So for education, knowledge graph can use it for course content visualization. It can be used for learning path and material recommendations, and it can also be used for university course management. So there are two types of KG or knowledge graph in education. It can be used for teaching and it can be used for learning. But usually the knowledge graph in education are constructed manually, so it is very expensive. So there are attempts to make it more scalable by using technical techniques such as rule-based methods and also machine learning methods to get the triples from the teaching materials. So a rule-based method is basically the way it works is to use an algorithm to find the root verb of a sentence. So like is a back in our example in the beginning, and then find the corresponding subject and object to construct the triples. But the problem you see here is that the result is not particularly good. So we have relationships such as two-dimensional data in figure 4.22, so useless, right? Not useful. More compact trees finding optimal test condition. Again, this is not useful relations for a knowledge graph. So the advantage of a rule-based method is that it can get acceptable result. You don't need to train a model. It's flexible, but it has a lot of trivial triples and a lot of important information of the domain. The context is actually missing. So another way to do it is, of course, using machine learning methods. Okay, we do it a lot recently. So there are basically two key components. One is name entity recognition. So that is to basically find again the noun, so the subject and the objects within the teaching materials. For example, we can get searching algorithm and algorithm. We can also then use the machine learning methods to get the relationship. So once we get searching algorithm and algorithm from the name entity recognition, we'll be able to get, it is a searching algorithm is a subtopic of algorithm. So this is basically how the machine learning method works. So the advantage compared to rule-based method is that it can handle more complicated relationship. But the problem is that it needs a lot of data, and it is not designed for long text like textbooks of documents. So the problem we have for existing methods like rule-based method or machine learning method is that the knowledge graph generated will have low accuracy. So this is because that extracting abstract concepts is a challenging task, and often educational concept name in text can be inconsistent. Another problem we are having with the knowledge graph generated by rule-based and machine learning is that the KG can be redundant because the existing method simply trying to extract as many triples as possible. And also a large portion of the relation we get is actually trivial relationship. So due to these challenges, the authors has proposed a framework that has 4 key elements. So the first element is to design a standard ontology for the relationship and for the data. So basically it has 2 parts, the entity attributes like the Wikidata ID, the Wikipedia link, and then also the relationship definitions. So we can see at the bottom side, the subtopic of, equivalent to, that sort of things. So once we have this ontology, we can use it to filter the raw data from the textbook, from the meta book, from the CSO, to reduce the size of the raw data and to make it more standardized. And then what we do is to use and then we put it into a backbone for the knowledge graph to make it structural. As you can see here, a hierarchical relationships. So how we can do it is to use the taxonomy from Wikidata and CSO. So you can see here we have at the top, on the top left, we have computer science and then machine learning. So obviously machine learning is a topic of computer science. So this is how we get a hierarchy from more some open data like Wikidata and also CSO. And then once we have this, hierarchy, and before that we filter it with the ontology, we have a knowledge graph backbone. But what we want to do more, we want to get more to make the knowledge graph larger from unstructured data, and we do this with a MRC process. So MRC stands for machine reading comprehension. And then once the machine get the unstructured data, it attached it into the knowledge graph backbone to make the knowledge graph larger. And the author has used a method, a pre-trained model called Roberta. Okay, so you can also find this, it is a pre-trained model. It's relatively easy to use from what I gathered from the author. So what it does basically is that you can input it with a context. So Python is dynamic typed and garbage collection. That is the context. And then we can ask the MRC model a question. So who proposed Python? And then the pre-trained Roberta or the pre-trained MRC model can answer, oh, Python is proposed by Guido van Rossum. I hope it pronounced correctly. So this is how we can get additional relationship by a MRC model. So here on the left side, you'll see some of the actual question we have used it. The authors have actually asked it the MRC model, and they have also used it for their knowledge graph. Okay, and finally, to make the knowledge graph less noise prone and remove some of the errors, the authors has also proposed the fourth component, which is the active learning. So what is happening basically is that the authors have also trained a model to tell whether a relationship is good or not. So if that model say that a relationship is bad or noisy, it will say, okay, this relationship is not very good. So we give it back to the human, and the human will annotate again to improve the knowledge graph. And this is one of the knowledge graph that is generated by the method proposed by the authors. So can we play the video? So the knowledge graph can keep growing because the authors have used the proposed method to generate quite a large knowledge graph. And the knowledge graph is not bad as well. Compared to knowledge graph generated by rule-based method and machine learning model, you can see the accuracy is much higher. So in conclusion, the authors have proposed a framework for constructing knowledge graph, which compared to existing methods is higher in terms of accuracy and lower in terms of redundancy. So thank you very much.
Thank you.
Thank you.
Any question in the room? Okay.
Oh.
Hi, yeah, thank you for the talk. My question is kind of a cross question with a talk you gave yesterday about the metaverse. So could the knowledge graph also be used to help students find topics or find modules they want to choose when they are at university? So could you combine this work with the metaverse work that you presented yesterday?
Yeah, thank you very much for your question. So yes, I believe so. And the reason is because my favorite part for this paper is that it is able to expand the knowledge graph with unstructured data. So we know a lot of time that teacher basically can't, say, wow, okay, so you learn this concept and then therefore this concept is useful for this thing, right? There are many possible applications for learning particular concept. So this is where this paper can come in. It can get extra information for a particular educational concept from unstructured data. So a student will be able to say, okay, for example, I want to learn JavaScript. So what I can do with JavaScript? So these kind of unstructured data could, expand the applicational, things that are related to JavaScript, and a student can tell, oh, I like JavaScript because of it is able to use for web game development, which the teacher may be not able to tell the student because the teacher is not familiar on that side, but this kind of unstructured data mining can add to the concept. So yeah, so I believe it can help student define which concept is suitable to him. Yeah, thank you.
Okay, great. Thank you very much.
Thank you very much.
Thank you. Any other question? The room? Any question online? No? Okay, thank you very much.
Thank you very much.
Okay, then the second presentation of today is extracting the language of the need for urgent intervention in MOOC by analyzing text posts. That I'm not sure the presenter, maybe is Leila. Leila, okay, Leila Al-Raji.
Yeah.
So when you want, you can start.
Okay, hello everybody. Can I share my screen, please? So are you see my screen?
Yes, we can see.
Okay, thank you. Okay, thank you so much to give me a chance to present my research. I am Leila. I am a PhD student from Durham University. Today, I would like to present our research. It's with the title, Extracting the Language of the Need for Urgent Intervention in MOOCs by Analyzing Text Posts. I will cover these points. I will start by give a brief introductions about the problems on the MOOCs, and then what is our research questions, then the methods that we use to answer these research questions. After that, how we can extract the urgent language, and then what is the tools that we proposed for the instructor visualization aid, and finally the conclusion about this research. So the big problem in the MOOCs that the only way to communicate between the instructor and the student is via discussion forums, which is a major tool for communication, and it generate large amount of posts, and these posts contains unstructured text. But the problem is the huge number of posts and the number of learner to instructor is imbalanced. As we know, it's the MOOC environment, it's open environment. So a lot of learners with a less number of instructors. So it's very challenging and time consuming for the instructor to monitor and detect which need urgent intervention. At the same time, we found that sometimes the learner may use the urgent language inadvertently. So we tried to solve this problem by understand at the beginning, what is the urgent language? So here we define in this research, the urgent language is the frequently words and the phrases that the learner use in their post when they need urgent intervention from the instructors. Our research question here, for the first research question, can the language of urgency be detected from a learner post? And the second research question, can the language of urgency be visualized in a simple and intuitive way? So to answer these research questions, here are our methods. We start at the beginning by collecting some data, then we do some pre-processing, then we clustering as I will explain later. Then we extract the urgent language and we propose some instructor visualization aid. So we used here in this research the Stanford MOOC post dataset. This dataset is available for researcher on request, and it contains learner posts from 11 courses. This data contains inside the post for the learners some variables. One of them is the urgency, which is contained the scale from 1 to 7. Which describes how urgent the post is. For example, if it's 1, that means it's not urgent, and if it's 7, it's very urgent. Then we formalize our problem by convert the problem to binary, as if we suppose that if it's greater than 4, so we suppose it's urgent, otherwise it's non-urgent. As I mentioned before, the dataset contains 11 courses. So we selected the Science Right course because it contains lots of posts, about 5,181, with about 34.2% as an urgent, suppose it's urgent. Then we start by pre-processing. We do some pre-processing as we tokenizing and splitting the sentence into a list of words. We do some cleaning, removing unnecessary words, and something about the learners' emails, their emails, any information about them. Then we build the phrases based on bigram, which mean 2 words come together, and trigrams, which mean 3 words come together. After that, we applied the lemmatization, and finally we removed the step words. Then the big questions, how we can extract the urgent language. So we try to clustering the words into the word that contains in the post into different topics. Based on the unsupervised statistical model, it's called LDA. But here the question, how many topics we should give the model, the LDA model, to build or to clustering our words. To answer these questions, we try to find the coherence score and what is the best coherence score. By applied different experiments, and in the same experiment, we try to increase the intervals, starting from 2, the number of key. I mean by the key is the number of the topics number. So I start from 2 until we reach 20, and we found that number of 6 is the best key or the optimal number of topics. That's why we selected number 6, and based on the number 6, we clustering our words. Here is the results, and we found that there are 6 topics, and on each topic we have some different words. And here just I present the top 10 words on each topic. Then, as I mentioned, our final goal is to find and extract the urgent language. So to reach this goal, we start by thinking about what is the dominating topic on each post. For example, here, we try to find the dominating topic for the first two posts. As we know that each post contains different words, and each word is come from specific topic. So what is the dominant topic that covered this post? For example, here in the first and second post on our data, we found that the dominant topic is about it's number 3, topic number 3. And the contribution is different. Here, topic number 3 is contribute about 0.53 and here about 0.47. After that, to extract the urgent language, we just calculate the topics that contain the dominant topic. It's contained about 80%. And on each topic, so we go to each topic, we have 6 topics, and on each topic, we calculate just the post that belongs to this topic if it's contained a percentage of contribution more than 80%. And we found here is the results and found that the topic 5 contained the most urgent. That means topic 5 contained the most language that the learner used when they need urgent intervention. But the question is why it's about 58 only. We want to understand more about these topics. That's why we focus only on the topic 5 and we try to inspect manually. As we know that the discussion forums there are 2 types of the post. One of them is called thread, which is the first post that the learner starting if they need anything to write, and the comments that reply, maybe the reply from the instructor or from the other peers. So in the literatures, we found that there is a research supposed that the first post tend to be a question and the reply may be an answer or comment on the question, which may they use the same language. And we take the topic number 5 and we inspected their post and we found that number of a thread in the topic number 5, about 96, it's urgent. And only 41, it's non-urgent. That's me. Here, the 59 is just reply to the urgent topic. And that's why they use it the same language, but it's not urgent. Then we move here, we know how we can extract the urgent language. Then we move to help the instructors and give some aid to help them. We start by to understand that to enlighten the instructor and show them the topics that contains on the specific course. We show the cloud word, which is contain the 10 most words that or terms that represent each topic. And here we can find with different colors. And after that, we give them the tool. This tool is called PyLDA visualization, which is an interactive way that the instructor can understand more about the topic, about the terms inside the topic, and the interaction between different topics. And at the end, we try to visualize the post in different colors based on the colors of each topic. For example, here we can help the instructor and also the learner to understand when they see the comments or the post that each color that means it's belong to specific topic. For example, here the instructor, if he find lots of color 8, which is topic 5. Here color 8 is topic 5, and it's a thread. It's most likely it is need urgent intervention, and here we can help them and find quickly that post that need urgent intervention. The conclusion for this research, the main challenge on MOOC's environment is the instructor intervention. As the nature of these discussion forums, it's a large number of posts with a low number that need urgent intervention. At the same time, the imbalance between the number of instructors to the learners. We show that learners express the need for urgent intervention using special languages. We can extract these languages to help both the instructors on their intervention and the learners when they're writing to understand if they need urgent intervention with some special words. And finally, with visualization, some these topics and the terms, and we can employ these visualization tools to aid in the comprehension of a learner language. And thank you for your listening. And if you have any questions, just ask me. Sorry, I can't hear.
Hello, sorry, the microphone had to get to me first. Thanks for your talk. My question would be, you said that you noticed that a lot of urgent language was used in the responses to actually urgent questions. Did you look into kind of already answered urgent question, or already like things that are no longer urgent because another learner might have clarified or answered the question already, so that you can highlight to the instructor this question was urgent, but it has already been answered in the discussion underneath, and this is still urgent because nobody answered the question yet?
No, our main focus here in the literatures, we found that lots of research focus just to do it as supervised learning, to extract or not extract, sorry, to classify if this post need urgent or not urgent, without taking into account if it's answered already or not. Just based on the post itself, we try to classify need urgent or not urgent. In other research, we tried from the other perspective. We tried to understand the topics and the language that use it to need urgent interventions, but we don't inspect if they already answered or not, no.
Okay, thank you very much.
Thank you.
Thank you. Any other question in the room? No? Any question online? No? Okay, thank you very much, Laia.
Okay, thank you. Thank you so much.
Okay. The third talk of today is providing meaningful digital competence assessment feedback for supporting teachers' professional development. Is there for this presentation here? No, I think they are not here, so we are continuing with the next presentation, that is using a mock to train teachers to design and deliver mocks. I'm not sure the presenter, Carlos Vaz de Carvalho, is here. Carlos,
hello,
yes?
everyone.
Okay.
Can you hear me?
When you want.
Okay, so first of all, I have to apologize for the conditions. Right now I'm away from office, so we have to deal with the not so good connection. But anyway, hopefully this will go as smooth as possible. So first of all, very nice to meet you all. And what I'm going to present to you is the result of a project that was developed in the scope of Erasmus Plus program. Between the Polytechnic of Porto, the Fachhochschule das Mittelstands in Germany, Kaunas University, Timisoara University, and Anadolu University. So a group of 5 universities in Europe. And all these names are my colleagues that were participating in the project. Now, the project itself, first of all, I'm not sure if I'm sharing the screen or not.
No, you are not sharing.
So maybe it's better if I share the screen.
Yes.
Okay. Okay. Are you okay? Yeah, I guess you are not actually seeing the presentation, but the PowerPoint. Okay. So the MODIT was, like I mentioned, was a project, collaboration project between different universities. And the two major results coming out of this project were actually self-assessment tool for teachers from higher education. And this self-assessment tool is an online standalone tool that allows teachers to assess if they have the required competencies to design MOOCs, and especially to integrate MOOCs in their own traditional, let's say, teaching processes. And then the second result, which is what I'm going to present here today, is actually an online training program to help teachers to develop these skills, the necessary skills to be able to design and deliver MOOCs. And these two results are related in the sense that the self-assessment tool identifies weaknesses and recommends specific modules from the second result. So there is an interconnection between the two things. The MOOC currently is available on iVersity, so the result is available on the project website, but also has been transferred to iVersity, so now it's available as a free MOOC if you are interested in this kind of training and competence development. Now, the reason for this is very much connected with the previous presentation, and I guess also with that absent, because it relates with the changes in higher education, but also with the existing issues in terms of competencies on teachers, but and still the issues with the MOOCs, because MOOCs provide the MOOC format, the massive open online courses provide a very flexible environment, but we know that they still have huge problems in relation with dropout rates. So typically, dropout can go from 90% to 95% of the enrolled students, which is very high. It means that normally only 5 to 10% of the students finish the MOOC. So we thought as a project, as a consortium, that we could combine the traditional way of teaching and learning with approaches and with activities that were based on MOOC format. Of course, this project was actually planned before the pandemic, before the COVID pandemic, but became much more relevant and much more important when we are all, I guess, forced to become online educators, and most of us had no experience on that. So it was really preceding the pandemic, so that was very interesting for us to also be able to assess how we could have helped the teachers in that moment. One thing that we identify, like I mentioned before, was the need to actually provide these competencies to teachers. Most teachers, when moving to online education, they tried sort of replicate their usual practices in the classroom, which of course normally does not work. So that's the reason behind this, the MOOC that we created. The MOOC was divided in 5 modules, and still divided in 5 modules. If you go to iVersity, you can check these modules. These modules were created with the idea of being standalone, so you could just go to a specific module, and probably based on self-assessment that you might do with the tool. And in terms of the first pilot testing that we did, actually most of the students were following the entire MOOC, so the 5 modules. We created this MOOC thinking on workload of 12 hours per module, and expecting the student to go through 1 module every 2 weeks. So in total, we were considering about 10 weeks of work. But actually, for the pilot implementation, what we did is to actually extend this 4 more weeks for a 6th module that is not available on the iVersity version, because this 6th module was actually supporting the teachers to develop their own MOOC projects. So we helped them already to introduce MOOCs in their own practice. The methodology was mostly based on self-learning and autonomous learning, but we have included in all the modules several peer learning activities, so that there was some collaboration between the learners. So some images from the modules that you have available. Some information about our learners. So we have 52 learners which were teachers in universities and other higher education institutions coming from Germany, Lithuania, Portugal, Romania, and Turkey. And the age distribution was very balanced. There were more people from 30s and 40s, but it was not a big difference. And then basically what we asked these participants was their perception and their ideas about the training. And just to be quickly, so one aspect that was important was if we reach the objective of reducing the dropout rate, and what we saw was that we had 33%, so basically 1/3 of the participants reaching the end of the MOOC, which is a considerable improvement in relation with the usual numbers, which is 5 to 10%. We still have a big dropout, of course. We have to accept that and to admit that. So 2/3 of our students didn't complete the MOOC, although they follow, let's say, the most basic and theoretical ones, and probably because they already had some technical information that comes from the other modules, they didn't follow entirely. So we have to say that we didn't fully solve the issue of dropout, but we sort of improved in relation to the existing numbers. In general terms, I'm not going through in detail with the evaluation of the teachers. You can have this information in the article, but it was quite positive, their opinion, in terms of the structure of the MOOC, the duration, the workload, contents, and the mix of autonomous learning and peer learning. They consider that they improved their skills and knowledge in all the modules, although their favorite model was actually the model that was dedicated to the course design specifically for MOOCs. And they were also very interested in the content production, so different technical ways or technologies to produce content for MOOCs. In general, they also think this is very relevant for their career and their competencies and development. It's very curious because there is something that was mentioned in previous presentation about the interaction of the teachers with the students, which is something they felt that the teachers were not always so present as they would have liked. So the facilitators for the modules sometimes did take some time to answer. So probably because they didn't really understand the importance or urgency of some of the messages, and that was a comment. And these are the general conclusions. So we show, we see that there was high satisfaction from the teachers that were involved. They like the structure, they like contents, the organization, the workload, and the relation between the different methodologies, pedagogical methodologies that were applied. They would have liked, some of them would have liked to have more interaction with trainers, but they all feel that, in fact, they are now able to integrate this MOOC format in their own teaching practices. So this is a sort of marketing approach to invite you to go to the diversity course, which has the same name as I presented here, and find this MOOC, and if you're interested, just follow it. Okay, and basically that's what I had to present here. Thank you very much, and if you have any questions.
Thank you very much. Any question in the room? No? Any question online? No, I have one question, because it's a very interesting topic. There are many topics in the MOOC course that you have presented. I understand that there are some support at your university, for teachers, for example, record animations or not, or everything is the teacher that do every part of the course?
Well, we sort of assume that there are different conditions in universities for this. So we know that in some universities, there is a technical support team that helps teachers to develop contents. So teacher only is concerned with, let's say, the content. But we also know that in other universities that is not true. So the teacher is sort of responsible for doing everything. So what we tried in this MOOC is to focus a little bit more on the kind of tools the teacher can use in an easy and simple way to create contents. But we understand that this probably does not apply to all universities, because some universities have, in some cases, very extended support teams to provide all the, let's say, the production tools.
Okay, perfect. Thank you very much. So
thank you.
Thank you. So the next presentation is designed a game-based learning environment for college student campus learning, presented by
Yixuan Wang. Yes.
Thank you.
Yixuan, thank you. Yes. So is my voice okay? And did everyone see my screen? Hello?
Yes, sorry.
Okay, thank you. I just want to make sure. Thank you very much. Okay, so greetings everyone. It's my honor to be here online to present my study. The title of my paper is Design a Game-Based Learning Environment for College Students Campus Learning. I'm Yixuan Wang, and I'm from Department of Educational Technology, Tankang University from Taiwan. And actually now it's the midnight in Taiwan. So it's a very a good experience to participate in the online international conference. And my paper is actually being accepted as a poster category. So I will present my preliminary study to everyone. Okay, so this is today's outline, including introduction, game design, game evaluation, and the pilot study result and future work. So here comes to the introduction. A lot of studies have revealed that learning technology can support learners' motivation and engagement. And the game-based learning way is a good way because it can be as a scaffolding, and this scaffolding can help students to do try and error activity. And during the gameplay, learners are being able to set up their goal and to achieve good learning achievement. And the learner can being able to learn things through the gameplay. They try to struggle to the goal, and then they are being able to achieve better learning motivation or learning achievements. So we also know that game design is an important issue. Researcher had proposed the 4 elements in game design, including story, aesthetic, and mechanic and technology. And these 4 elements are very important because the 4 elements will determine the goal of the game, the sequence of the event, let's call the game, and how learners feel and experience the game, and also what medium makes the game possible. Okay, so in this study, in this preliminary study, we do 2 things. First, we want to explore how to design the game following to the 4 elements. And then we do a pilot study to understand how the college student, how their learning performance and perception toward the developed game for campus learning. So here comes to the game design. Okay, so our game design, the purpose of the game is we want to help college students to become familiar with the campus and to learn the policy and the surface that the first student might be know. So this is a picture we draw for our game. So first, the story element. The game starts with an animation, which describes a story about a member of a university was being stolen, and the learner had to find out who might be the possible criminal. So they will play as an avatar and to explore the environment in the game. And during the exploitation, they will learn the policy, the surface of our campus. Okay, so this is the story. So the aesthetic of the element is you can see that the avatar we drew is a cartoon figure, and the game background was designed following to our real world setup. For example, the game map and the location of a building of the school were created according to the real environment. So you can see in the middle picture is the picture we draw of the building. And in the right side of the picture is the picture we took from our campus. So we try to make the two things similar to help students connect the game scenario and the real scenario. Okay. So you can see the right picture is the Google map of our school, and we try to follow into the Google Maps. And then we set up the game map of our campus. So you can see this is the avatar, and the student can use the keyboard to control the avatar to explore the environment. Each yellow spot means that the learner can enter into the building and to explore the building. Okay, so you can see this is all the building that we draw, the real picture. Okay, and the picture we draw to use this object in our game. Okay, so this is it. And we also took a lot of picture from our school to integrate the picture into the game to help learner to play in the game. They also can see the real part of our campus. Okay, so the technology element is that we develop a game based on HTML5 website. So the learner can log into the game through their personal computer as long as they connect to the website, internet, sorry. Okay, so the mechanics of the game is the game mission and story bridge will design the game. The learner will answer to the question, and the question will be recorded, and the result will differ according to their score and their choice. So you can see this is the different one of the choice. The learner achieve the goal, and this is the very best the result. Okay, and this is the recording of the time they find the building or the score they answer to each question. Okay, so this is the more picture, the story, the game map in the middle, and we also use some question to information learner have to read, and then they have to answer the question, or they have to use the avatar to go through the map of the building and find out the criminal. Okay, so this is the picture of the game. So the game evaluation, because it is a pilot study, so we invite a small group of college students, 70 students in the first year of college, were invited to a computer-based classroom to test the game. And so they have to finish the pre-test and post-test before and after the game evaluation. And the test was related to a problem the student met on the campus in the game. And actually the sequence of the item was the same. The content of the post and pre-test was the same, but we changed the sequence. And the interview was conducted after the post-test for collecting students' feedback after the game. So according to our pilot result, the pair sympathy test indicated that the learner achieved their scores. The post-test score were higher than the pre-test score. Okay, and we also collect students' interview feedback, and in general, the student gave positive feedback on their scan experience. But we also found that some students mentioned that the operational design could be improved. For example, we designed some hotkeys in the game to control or answer again, such as O, Q, or Shift. But the learner reflect that we have to use more common use key, for example, enter or space. That will be more good for them to control again. And then the learner also suggests that a game menu may be created so that they can go to different chapter of the game. This will help them to be more flexible and easily to access a lot of a different chapter. Okay. So following our game design and evaluation, in this study, we try to create a game-based learning scenario to help college students to exploring our campus through the gameplay. And we design the game according to the 4 elements: aesthetic, story, mechanic, and technology. And according to our pilot game evaluation, the student improved their score. But we also found there are some improvements we can do. So in the future, we'll try to improve the operational design according to learners' suggestion. For example, the control key will be modified. And also a chapter menu will be added in the game to help students to change the chapter more easily. And in the future, I think it will take some time to revise the game. And we will invite more college students to participate in the experience. And we also try to integrate different learning strategy, such as maybe they can to use the game in pair or to have some competitive. So we want to test wherever the game with different learning strategy will help students to have better learning achievement. Okay, so this is our hope to integrate the activity of the game to create a well-designed game-based environment to include our target learner, fresh people's learning effectiveness and learning motivation. And this is a pilot study, and more research from this research will be reported in the near future. So this is my presentation. Thank you for your listening. And any question, I will come.
Thank you. So any question in the room? Okay.
Yes, hello for your presentation. I was wondering, does every student have to know the entire campus, or are there some students that only need to, for example, know where the education building is and others need to know where the math building is? So that would also, I assume, change the pre and post test score. If before they only knew the building that they're relevant for them, and afterwards they learned about buildings, but in the real world, they will never have to go there. Did you take that into consideration, or is that not even an issue because every student needs to know every building on campus?
Okay, thank you for your question. Actually, in the student participating in the study are students from our college, our department. So actually, we refer to our school's book for fresh people. So we pick up some things that for general students have to know. So we didn't focus on particular department. So the content in the game we design is for general. Yes.
Okay, thank you very much.
Thank you for your questions.
Thank you. Any other question? Yes.
Hello. Thank you very much for your presentation. I like it. But I just want to ask about a minor technical detail because I'm slightly confused about it. I think I hear that you say that for the pre-test and post-test, the sequence is different. Did I get that? So may you clarify on the meaning of that? Because I'm curious on the swapping, the purpose of swapping the sequence. Thank you.
Okay, because we don't want the student to just memory the answer, but we want to make sure that the content we test student will listen. So we use the same, for example, maybe we have 20 items, 20 questions in the pre and post test, but we change the sequence so that student may not only memorize the answer, but they have to read the items and choose the right answer according to the minutes. Yeah, that is how we do in our pilot test.
Okay, thank you very much.
Thank you.
Any question online? No, I have just one question because I think it's really interesting in the topic. It's open source, the game?
Pardon?
Open source or not?
Open source, you mean for everyone can access in the game or the development tool I use?
Yes, if for example, any person from other university is interested to copy your code to adapt to for another university, is it possible or not?
Maybe in the future will be possible, but currently we use the content in the game is in Chinese. So if we want to share with other people for international, maybe we will spend some time to translate the language into English. But it might be possible in the future after we do some revise of the game, and maybe we can share the link with others so everyone can learn Chengdu University in Taiwan.
Okay, thank you very much.
Thank you very much for your suggestion.
Thank you.
Thank you.
So the last presentation of today is Gamifying Experimental Learning Theory, presented by Amani Askakab and Frederick Belli. Is presented. Okay.
Hi, this is Amani.
Okay.
Can you see my screen presentation?
Yes, yes.
I'm presenting gamifying experiential learning theory. I will cover a general introduction, the process of gamification, and showing an example of game prototyping, also the results, and I will go briefly through the extended work. Motivating students to learn and enhance their performance can be done by gamifying existing learning system via adding some game elements, or educators can achieve similar results by developing dedicated games for learning purposes or complete game-based learning. The aim is to support both game designers and educators filling the gap in their cognition and knowledge. Gamification would lead to smooth transformation of learning theories to game elements and mechanics. The concept of gamification usually applies to a lesson or field trip, but it can also be utilized to gamify learning theories to design educational games. As the lack of theoretical foundation could limit the effect of game-based learning, so the focus of this study will be on learning theories. Many learning theories used for the same purposes, such as cognitive theory and collaborative theories. However, the experiential learning theory is selected as it considers experience to be the central source of the learning and development. There are a few attempts in the literature to model the theory, but these attempts lack or ignore important elements such as interactions, assessment, or ignore game mechanics completely. The experiential learning theory consists of 4 stages: concrete experience, reflective observation, abstract conceptualization, and affective experiment. Those 4 stages have to be completed in a cycle from starting from any stage. How to do that? The gamification is achieved by mapping the theory to internal economy. The internal economy is a type of game mechanics which handles the flow and transaction of game elements that are considered resources in gameplay, such as points and lives. The main component of internal economy: resources, internal mechanics, and feedback. A resource is any object that can be quantified numerically in the game, such as enemies and munitions, and can be stored in entity. Resources flow from one entity to another regarding 4 internal mechanics: source, drain, converter, and trader. For example, the resource mechanic produces new resources and stored them in entities, such as creating new dots in the Batman game. The converter changes one type of resources to another. When a resource that results from a specific mechanic feeds back and affects the same mechanic at a later time in the game, it's called feedback loop. There are two types, positive and negative. For each stage of the theory, resources are defined with suitable internal mechanic and feedback loop when needed. The game mechanician is utilized to present the process of gamifying the learning theories aspects. The game mechanician framework is a tool to visualize game mechanics. The symbols of the game mechanician are a way to facilitate and support the modeling of internal economy in a graphical representation. For example, the cycle, the open circle represents entity where resources are stored, and the triangle pointing upward represents source mechanic, while the solid arrow represents the flow of resources. It is a model of students' progress in reaching different stages of the theory cycle while performing tasks. By completing a stage, the knowledge and skill of player will be expanded to show progression in performance. 4 stages or 4 resources are defined, each of which represent different level of achievement and associated with a specific stage of the cycle. For example, after completing the first stage, the player is expected to generate resources called observation by completing the task and exploring the game environment. For the second stage, the player should reflect on the observation of the first stage, while the third stage, the player should synthesize and plan to do experiment in the following stage, which is the 4th stage, when the player do something and experiment. Going back few steps. Here in the first stage, it mapped to a simple internal mechanic where the player grasps knowledge and it is conceptualized to interactive source task. The difficulty of the task is demonstrated as a gate with a player sample and probability of successfully producing level 1 as P1. For example, P1 could be 50% chance of accomplishing the task successfully according to the player's ability of making observation resources and storing them in the level 1 pool. The second stage, represented by a source reflect, it can be generated in one of 2 different scenarios, where whether or not the player completed the task in the first stage successfully. In the first scenario, as a resource stored in the level 1 pool, the reflection will be triggered automatically by the trigger state connection that links level 1 and reflect, as it expected to reflect when the player has successfully accomplished the task. The second scenario, which applies if the task couldn't be completed, the gate guarantees the redistribution of the player's experience by P2, where P2 represents the probability of the player's ability to reflect when the task is not completed successfully, showing that she or he learned something even from the mistake. The same concept will go with the third stage and fourth stage. Before starting a new cycle, the player is expecting some feedback as a result of the evaluation. The source generates symbolize the feedback provision, which will be triggered automatically by storing resources in level 4. The generated feedback will be stored in feedback pool, and the player is expected to act on this feedback by clicking on the interactive converter, which will produce action resources showing that the player is utilizing the feedback to improve or fix something in the task performance. Working through the whole cycle and acting on the feedback will improve the knowledge and skills of the player, which will raise the probability of completing tasks successfully in the following cycle. The following step, which is the matching scheme, enhances the gamification process by linking the internal economy representation of stages into specific game elements. Game educators and game designers and educators can utilize all the elements in the scheme or select what fits their learning objectives. For example, the concrete experience needs interaction and mystery to encourage the player to explore the learning environment, the game environment, and gaining information from observation, while the active experiment requires consequences for the experiment that the player doing it. Now I will go through the implementation. The implementation of this gamified model is based on field-based learning gaming. The prototype provide virtual learning field trip game for secondary school students, and it is an experience of surviving in Iceland of volcanoes by observing, collecting data, and planning, and then acting on that plan. The resources of each stages, along with their flows and internal mechanics, are defined. For example, for the first stage, the player needs their previous knowledge to produce the observation of the volcanoes island. The task in this level was about shooting fires and collecting some kind of rare stones. Then the player will fill their water tank to shoot the fire. The idea behind that is to explore the environment, the game environment, as we can see here. The game started in the island with fires and stones, and the player expected to shoot those fires. The purpose of that is to explore the island, to know how many volcanoes. We can see here the view from upper side. Also, the player can learn more observation because one of the volcanoes contain lakes. Going back. Using feedback in this stage, positive is feedback. If the player, when the player shoots more fires, he will explore or she will explore more of the island and gain more knowledge and observation. For the second stage, the player will use their observation from level 1 to collect information. The purpose of that is reflecting on the situation. First, they found 3 volcanoes on the island. They need to collect information about these volcanoes. They will be using some learning resources here. If we can see this sign, connect the player to web page, alerting. It's a real web page with live data showing which one of these volcanoes could be active during this time of the year. Same concept will be is used already for the 3rd and 4th level of the learning stages. Again, the next step is linking these resources to some game elements from the matching scheme. For example, for the first stage, multimodal representation is employed through different forms of learning materials. The information that provided for the player, it wasn't just from the observation, but also some text provided and some videos provided to the learner. The narrative is introduced to the learner via Red Dragon. Also in the second stage, the player encouraged to reflect on the observation by collecting more data. For the third stage, there was some signs, natural signs, sending to the player to understand the environment, such as gas or lava from the active volcanoes. Also for the assessment, awarding points and badges are used for the feedback, multimodal representation, like color, showing that the answer is wrong if the color green, red, and the answer is red, right if the color is green. Control choice provided to the learner to give them a chance to work on the feedback and fix the mistakes. Two chances are provided. The Iceland of volcano represented Bali, which has 3 volcanoes. One of them is active. The learning content was based on the natural hazard from curriculum in England, case stage 3. These are some of the screens from the games showing this is the start, this is the resources of that provided for the player. For example, the player, if he shoot more fires, also he will gain some coins. This will help him or her to survive if the volcano become active. If it is producing lava, they can purchase a boat and leave the island. If it's just gas and it is not red warning, then they can use the car to leave, to go far away from the dangerous volcano. Here is where the player collect the information they collected from the Iceland or from the web page. The evaluation. The first evaluation was about collecting the expert's perception of the model. A questionnaire was designed to measure the mapping, the usefulness, and the usability of the gamified model. Also, some demographic information is collected. The result of the test showing that the participant expressed agreement regarding the mapping between the stages and the internal economy, and showing that also the model was found useful, and also for the usability, SUS used to measure the usability of the model. The participant asked us question about if they will use the model in the future. Most of them showing their intention to use the model in the future. Some of them said they will not use it because it's not their area of research. Also, they asked for more explaining about the assessment and the skills, high-level skills. This will take us to the future work or extension of the work, which already has been done. The model is extended to be a framework by modeling more theories, social learning theories, task-based learning, and also high-order skills are added, such as teamwork skills. Also, a mathematical model is designed to assist in-game the performance of the player by defining indicators of gaining knowledge and skills of based on the player's interaction. And also this prototype is used in experiment with the students from secondary school, and the performance is collected, the log data, and also questionnaire of their motivation, the pre and post test already done. Thank you.
Okay, thank you very much. Any question in the room? Okay.
Thanks for your presentation. I would like to know more about the connection between and the difference between gamification, gamification education, and with your approach of game-based learning, because you use, you know, game elements to apply to the design of an educational game. I'm not sure what kind of game elements came from the gamification, area or field, and what are the difference or the link with your approach that, in my opinion, is game-based learning.
Yes, at the end, we can have game-based learning, but the way to reach this game-based learning is starting from gamifying the theory. The theory transferred to specific type of internal of game mechanic by gamifying the theory. How I did that? By defining resources, internal mechanic, feedback for that theory.
Okay, and what kind of I would like to know also if you in the proposal of your gamified theory, you what are the sources that you have, or have you worked with have been working with experts of the game field or area, or educational professionals, some projects that mix different, because it's education and games design, game studies.
Yes, I work
and
with my.
Are you involved also users in or testing the model that you propose, the prototype?
I worked with my supervisor, Frederick Lee. He is a professional in game design, and also I worked with some doctors from the School of Education in Durham University. Also, the first method of evaluation, I took feedback from some experts. The questionnaire here that I used, I provided this questionnaire for experts in education, and some of them was also expert in game designing. And the feedback from them, I used their feedbacks to extend the model to be a framework. Some of their feedbacks was focusing on assessment. Some of them asked for high level skills to be included in addition to gamifying the theory.
Okay, thank you.
Thanks.
Thank you. Any other question in the room? Yes.
Hello, yeah, thank you for your presentation. I'm interested in your use of the SAS questionnaire, because it was designed to evaluate applications and how useful they are. So how did you use it to evaluate a model?
The questionnaire is used to evaluate the model. I provided the model to the experts with some statements regarding the mapping, few statements regarding the usefulness, and I used SUS, which is well-established questionnaire to measure the usability. But about the application, the prototype games, I use different way of evaluation, which is experiment with pre and post test. Also, I had two groups of students. One played the game and the other one had the same lesson, but by their teacher in the traditional way. After that, I collected some data inside the game and analyzed it. Also, I analyzed the pre and post test results.
Yeah,
but
thank you.
it was different. It was the extended of the work. It wasn't included in this paper.
Yeah, but you said you used the system usability scale, and that has questions like, I would like to use this application again, or I would need the help of a technical expert to get started using this application. So how does this apply to your model?
It wasn't about the application, the questions about the model itself. I provided a detailed explanation of the model with examples to the experts. They read it, the model and the examples, and after that, they answered the statements.
Yeah, but the SAS questionnaire has statements about an application. How did you use it for your model?
But it used also for models in the literature.
Okay, I see, thank you. Then a second question, why did you start out with an educational model and gamified it rather than starting out with a game model and adding education to it?
I started with a theory, with the experiential learning theory, because game-based learning or educational game, lacking of theories make them just a game without giving the player a way of gaining knowledge.
Okay.
After
thank
that,
you very much. Yeah, no, that answers my question. Thank you.
Okay, thanks.
Thank you very much. Any other question in the room? Any question online? Okay, thank you very much. This was the last presentation of today, so thank you everybody.